In this video lesson, we will define discrete and continuous functions and variables. So let's begin with discrete variables. I will encourage you at this point to pause and make sure you have your interactive notebook with you because you will need to have or take notes throughout this lesson. So discrete variables. We have animals, things, people, all of which can be counted. So I'm going to highlight this information. Discrete variables are those values that are usually counted. All right. An example of that are number of people in a classroom, number of pairs of shoes you have in your closet, amount of change in your pocket. All of these things are counted. Okay. But now let's think to what they are not. They cannot be divided into fractional parts. So I can't take your favorite pet here and cut him in half or cut him into fourths and expect this pet to maintain its value as a dog, right? Without harming the dog. It can't happen. I can't take this sweater and slash it in half or again into fourths and expect it to still be of use. Right? It has to be one complete sweater. And Solange, obviously, she stands on her own. She is indivisible. So these things, discrete data or discrete variables, are indivisible. That means they cannot be divided. Okay. So often you see that they are measured by whole numbers. Or if you go back, to before whole numbers, they are measured by counting numbers. Of course, we also have zero. So I would say mostly whole numbers there. So let's look at this part. First, in the middle here, I have a graph. So I have people as my X and the number of flu shots provided or given as my F of X, right? So if I have one person, they get one flu shot. If I have two people, they get two flu shots. Three people, three, and so on. Okay. Never along this path or throughout on this graph can I say, oh, well, I have 1.5 or 1 and 5/10 person, so they're going to get 1 and 5/10 of flu shot. Or I have 2 and 2 and 25/100 of a person. So they are going to get 2 and 25/100 of a flu shot. Because as we know, people cannot be divided into fractional parts. Right? So in this graph, none of these points are connected. I can't go and say, you know what, I'm just going to draw a line from here all the way to 5 and say all these things, all these little fractional parts are included, because they're not. Okay, we can only include the whole numbers involved in this scenario. So discrete data cannot be divided into fractional parts or pieces. It is counted, and the points on their graph are not connected. All right, again, if you want to pause it and go back and make sure you have those notes down, please do so, because that's important for you to have. So now we're going to talk about continuous variables or functions. So continuous variables or continuous data is something that can be measured. Okay, so I'm going to write that down here, measured. So what can we measure? Well, we can measure time. Right, all these fractional parts are included within time. I don't go from 1 o'clock to 2 o'clock and skip all of those minutes and seconds in between. My height is measured as far as I'll just be honest, I'm 5'4" on a good day, and if I wanted to jump to 5'6" by tomorrow, I would have to go through each and every one of those little inches and centimeters or whatever um, in between that to get to 5, 6, right? I can't just jump from 5, 4 to 5, 6. Distance is also measured, okay? So these are all quantities that are measured. If you think about the weight of an object, distance that you walk every day, the amount of time it takes you to get home, okay? And we include fractional parts or pieces within that. So if we look at this graph in comparison to the last graph, this is a line. I can start here at 3, or is that 2? I can start at this order pair 0, 2, and then draw my line up to show as the time increases, so does the distance. Because it's true, right? All those fractional parts are included in this graph. So this is an example of a continuous function or continuous graph. Okay. And if you take a note of some of the bullet points here, it says continuous data can be divided into fractional parts. It is measured. And our graph here, or our line, our graph has no gaps or breaks, and it is one line. All right, so now we're going to do an activity, which I like to call, is it discrete or is it continuous? All right, so I'm going to see, pull that down a little bit like that. Okay, cool. So we have the distance traveled from, let's say, Silver Spring to Philadelphia. We have the number of students at Francis Scott Key. We have the number of Subway sandwiches sold on Tuesday. I don't know, sold on Tuesday. Let's just leave it on Tuesday and Wednesday, just to add another day there. And the time it takes to get up, get dressed, and get to school. So go ahead and pause it if you want and figure out which of these are discrete and which are continuous. All right, so let's start with the number of students at Francis Scott Key. Well, is this data measured or counted? I could walk around and count the number of students and say, okay, there are 600 and something students at our school, or 800 number of students. I don't know for certain. But that is an example of discrete data because it is something that is counted. I could go to Subway and say, so how many sandwiches are sold every Tuesday or last Tuesday? And they will give me some concrete whole number, right? And so again, that's an example of discrete data. And if I were to graph it, and this is not an accurate graph, and these, I would have one dot here, another order pair there, another order pair there, and I wouldn't necessarily, I would not connect these because these are separate dates unless I'm showing some other information. Okay, all right, now we have the distance. Distance traveled from here to Philadelphia. Well, that's continuous because that can be measured. The time it takes to get up, dress, and get to school. That's another example of continuous data, or continuous, because again, it is time and it's something that can be measured. So lastly, we're going to look at this example here where, and you'll probably get this worksheet. It says, it says determine whether or not the relationship is a function. Okay, but more importantly on this part, we're going to be determining if it is discrete or continuous. So we have the distance a person is from the ground relates to time as they ride a roller, or rather a Ferris wheel. So let's imagine this. If I sort of start somewhere right here, and this is my time. Let me use my pen. This is time. And this is my distance, right? And I start a little bit off the ground, right? At 0. I'm going to go from here. I'm going to go up and then go back down, and then up and then down, right? If I'm imagining what a Ferris wheel looks like, right? I'm not going to stop here and then say, okay, you know what, time 5 minutes have passed, and then start up here. And then another, let's say 2 minutes have passed, and then now I'm down here. No, it's going to be one continuous graph. Okay, so I think this is continuous because one, it's something that can be measured. So I'm going to write under justification, distance and time are measured. Okay, so the amount of daylight during a day throughout the calendar year. So in this situation, I'm going to do another little graph. And it looks like, let's just do a week. So we have Monday, Tuesday, Wednesday, Thursday, Friday. So one day, let's say this is 8 and this is 7. Okay. On Monday, there were 8 hours. On Tuesday, there was 7.5 because it was cloudy, let's say. On Wednesday, it was another 8 something hours. 8. Friday, 8. Again, these are all discrete points, right? I'm sort of just saying, okay, this is 8, 8, 8, 7, whatever. But I'm not going to connect those because it doesn't tell, that's not really what this data is asking me to do. So this is an example of discrete data. Now, lastly, I don't know if you know this about cars or vehicles, but the minute they leave the lot, they begin to lose value. And this car has been around since, well, a long time. So 1978, which is really weird that they would have that as an example. So 1978, that's way over here, right? And this car was brand spanking new. So it began to lose value the minute it left the lot, and now it is worth junk. And each part of along the way can be measured or is a part of its depreciation. So this is an example of continuous data. All right, so this is what I want you to do. I want you to come to class and have this information provided as your homework. Make sure you have the notes from this class in your notebook because we will be using it in class. All right, bye.